Is my mic on? Yeah. Okay. So this talk is from PHP to machine code. It probably is the most useless thing you will hear today. It will teach, I think it will teach you nothing, but my goal is to give a sense of understanding on how computers work. So if you learn anything, it's the skill you can apply to any programming language, any tool you will use in the future, because you will know how they actually function down to the machine level. So my name is Joe. I've spoken here before on I think 2 years ago. I currently live in New York. Spend most of my days building all sorts of internet projects. And I was recently deported from the United States, so that's what I did when I was deported. I built this thing, which I'm going to talk about. If anyone wants to talk about immigration in the US, well, I can give a talk about that as well. Anyway, let's get to the real things. So the question I had is, when you type this in your little terminal, no matter what operating system you use, what does actually happen in your machine? I know I'm writing source code as a text file. It almost looks like English. I run this one command, and all of a sudden things come out, or probably a syntax error comes out. So I had no idea how it works. I needed to look into more. So I looked at C++. And C++, of course, has 2 steps. So you compile your source code first. Some magic happens to your source code. And then you run it on, I guess, the same operating system you just compiled. And then it works. So there are 2 steps. PHP seemed to have 1. So I started looking at that. And the first thing I learned was that a compiler, all it does, it just translates source code to, let's say, machine code. I'm kind of simplifying the concept of machine code. It compiles it to a set of instructions. So compilers don't really do any sort of magical things. They don't just, come up with things. All they do is translate your source code to machine code, almost like a one-to-one mapping. Especially languages like C, it's like sometimes very close to just a one-to-one mapping. You can like translate every line of C to a set of assembler commands, for example. But this doesn't seem to relate to PHP at all. So how does PHP do all these things? Well, PHP does all of this at runtime. Almost all of this at runtime. So that was kind of obvious. So of course, PHP doesn't have a compile step, so it has to be doing all of this at runtime. Still, I had no idea how any of this actually functions. It's not like I've not participated in the PHP internal, so I don't really know the fundamentals of that. So I was left to reading books, and that's very boring. So I tried to look at like faster paths. How can I actually learn how compilers work for languages like PHP without having to spend, months or years reading books and watching tutorials and doing all the things. So as a hacker, I was like, I know what I'm going to do. I'm going to build one. So an obvious resolution came to my mind. I was like, instead of trying to learn it, let's like hack together a project which would do that thing, which would compile PHP. So there's a saying that like everyone should write their own web framework and then never use it. I did the same thing. Like everyone should write their own compiler and then never use it again. And that's what I did. So last year, I built this project called PyHP. Like an obvious name, it has Python in it. It's all open source. It's all available on GitHub. As the name suggests, it's of course written in Python. There's a list of reasons why I did it in Python. I'm going to go in them in detail, but that's all it is. If you've done Python before, you can just go to GitHub, check out the source code, run it, and it will actually work. Python is a pretty simple language, so you can actually read the code very easily, and it's actually much more readable than at least the PHP core would be. So what sort of things does it do? Well, it runs any PHP except the usable parts. So it runs a tiny subset of PHP. Because I did that almost in a test-driven development way, where I was like, PHP source code has this file called bench.php, this micro benchmarks file. It has 10 different functions, and they test different things like array access, passing by reference, loops, if statements, all sorts of different things, or just calling a function 1,000 times. So my goal was, let's implement just that. Let's implement enough functionality. So I can run the bench file. It performs the same tasks as the PHP core would, but now written by me. So of course you can't run Symfony on it just yet. It's written in Python. It's very simple. It's just, I think, a couple thousand lines, and it's super, super fast. I'll come back to performance a bit later. It's very, very fast. It's probably at least three times faster than PHP 7. And I think it was 5 times faster than PHP 5.6. I'll come back why it's actually that fast. It also has some interesting features. So everyone has heard of PHP 6. And the problem PHP 6 tried to solve is that if you have a Unicode string currently in PHP, and if you try to access characters, what you expect to get back is these different letters. But actually, what you would get is 2 halves of the first letter. So you run it in any PHP installation right now, you get 2 question marks, because it's trying to print like half of the Unicode character. And because what I've done was just use Python, and Python is a Unicode language in the first place. It's the only existing PHP 6 implementation on the planet. And it actually works. Like this is not a fake slide. Everything in PyHP is actually Unicode, both function names, variable names, strings, everything is Unicode. So if you want to use Unicode and you want to be like PHP 6 certified, you can use PyHP. So that's that. So that's the fun part. Let's actually get to the basics. So before I come back to talking about how actually PyHP functions and the sort of logic I use for it, I want to go through the fundamentals of interpreters, I guess the fundamentals of compilers. So any programming language, any dynamic programming language has 3 steps like that. Python, Ruby, PHP, anyone you pick, I guess JavaScript as well. They all go through these 3 steps. You parse the source code first, you come up with these things called opcodes, then you run them. One of the first lessons I learned is when it comes to opcode cache, this thing you're supposed to be using, and I hope you're all using, is it caches these 2 first steps. So when you install opcode cache, when you enable opcode cache, all it does, it just skips these first 2 steps and goes straight to execution. Why is that? Because parsing doesn't change if the file doesn't change, and then of course generating the machine code out of it also doesn't change as long as your source code doesn't change. So when you install opcode cache, that's what it does. It skips the first 2 steps of execution. And of course, that's why it's so much faster to use opcode cache, and that's why everyone should use it, because it has no drawbacks, but it just skips the first 2 steps, which are repetitive anyway. So the first step is something you could do really, really fast. So even without using things like opcode cache, PHP can run through this super quickly, like in a matter of milliseconds. And the first step is to parse the source code file, which is just currently just a massive string, into a list of tokens. A data structure we can use to play around and then plug into different parts. Since PHP 7 also, if I'm not mistaken, PHP also has an additional step, which is it creates a thing called AST tree, which is the abstract source code tree. So we go from a source code file being just a massive string to a source code file being represented as a nested data structure, which then we can use to build further logic. So some of the tools which do static analysis for different programming languages, for PHP included, that's what they do. They parse your source code, they build a source code tree, and now I have this code structure I can play around and inspect your source code. But that's the first video. Most of the languages have these things called grammas. So even PHP has this, almost looking exactly the same, just 1,000 times longer, and in C. In PyHP, it's just a bunch of text. But all programming languages are exactly the same. They define the programming language as a recursive set of statements, which we can plug that in. Like you give us a parser this, and you give a parser a source file, and it's able to pick out these statements. So you can see in this how an if statement is defined. Like an if statement can have a comparison expression, a statement, or a comparison expression statement, and an else branch. And you define all of the language in this file in a sort of a format, and then you can build very fast parsers. And in this step, we also rename all the variables to numbers as well. So if I have a file like that, I call this function, PHP actually has a function for that. You can call token underscore get underscore all. It prints out all the tokens in my source file. Probably something you don't really want to look at unless you're building source code analysis or static analysis. But that's what tokens look like. You can see that every piece of code is now represented by a token. So we dropped like code-specific structure. We dropped new lines, we dropped spaces really. We can all remove all the white space, and now we're left with just a bunch of tokens. And then we can take one more step, and we can generate a nested tree structure. Of course, it's much more usable and much more easier to kind of play around with if you have a nested structure as opposed to just having a list. So that's what PHP does as of the latest version kind of internally. A neat thing I learned through this is that as you're doing source code analysis, source code parsing, and then you're like stripping out all the variable names and then just using numeric indexes because it's just faster, you can do a lot of like neat features at the same time. So when PHP added namespaces, all it does is that it takes the namespace from the top of the file and appends the string to every class name in the file. They're called fully qualified class names. So if you think this namespace support is some kind of a crazy execution time thing where it figures out where the classes are, where the namespaces are, it's not that sophisticated. It's actually very simple and basic where at the parsing time, I think, it takes a namespace, it takes all the class names, appends them together, and now it kind of removes the concept of namespaces. All it has left are these long class names with full namespace names. Pretty neat. It does a similar thing for traits. Again, you would think traits is some kind of clever runtime thing. It doesn't actually happen at runtime. You can do that while you're parsing the file. All you do is copy and paste every single trait block to a class. Again, I'm simplifying that. Of course, there's more involved, but that's ultimately what it does. It just takes a trait, every time it's used in a class, it just copy and paste the little bit of source code into that. That's it. So as you're seeing, as I'm parsing a file, I can already do some kind of optimizations and clever hacks to go from usable features just to still the same list of tokens. But again, tokens are not useful yet. We can't run them. So we have to come up with these things called opcodes. A list of opcodes is what's known as bytecode. And the best way I can describe what an opcode is basically a virtual assembler command. That's at least how I think about it. If you've ever written any assembler, and I kind of feel sorry for you if you have, that's what opcodes look like. If you actually dumped out the output of PHP, opcodes, they look like almost like an assembler command. We can cache these results, and we can also use a bunch of extensions or just an online tool to dump the opcodes for any source file of PHP. You can look at that and you can look for interesting things. So, if we look back at the same file we just had, and we run through this VLD extension, these 4 opcodes describe our source code. So we went from parsing it to having this AST tree, and now we generated a list of opcodes, which, ignoring all the kind of debugging information at the top, there's just a little assembler code I have. And it's pretty obvious what it does. It does variable assignation by numeric index, then it prints the numeric index, and then it frees the result because most of the statements return results, but that's like implementation details. And then the last thing is just returns the successful parsing. That's all it is. Like that's what you need for execution, is to generate this list of opcodes from a source file. It gets more interesting though. Actually, I skipped this up. That's what it looks like. But it gets more interesting though. So when I was looking at implementing that myself, the question I had is, if my list of opcodes is a flat structure, it's just a sequential list of commands, how on earth I'm supposed to implement if statements? How do I branch out into true and else branches depending on a condition if my bytecode is just a massive list? And the way it works is you use labels. So when PHP added labels, it's not a new concept. Labels has been around for a very long time. And actually, you can use labels to implement any conditional structure. An if statement, a while statement, a for each statement, a for statement. All these code block structures can all boil down to using labels. How does it work? So I have color highlighting to kind of showcase the logic in there. As you can see, my if statement is still there. So I'm comparing my variable to the string, and then I have a little jump statement. And that jump depends on the result. So if it's true, it continues running and then jumps here. If it's false, it jumps here and then continues running. That's how if statements work. That's how loops work. The only difference in a loop is that instead of jumping, or instead of continuing running, the loop would just jump back to the top and just keep running. That's all it is. That's how if statements and that's how loops work in the sequential manner. Like that, you just use labels and jump statements to jump around. Super easy. And then the last step we're left with is to actually execute our source code. So now that we have a list of opcodes, our bytecode, all we have to do is to run for every single one of them in a loop and execute a little piece of code for it. So if it's a variable assignation, we assign some variable, some memory block we have. And depending on the implementation, whatever the engine decides to do with it, it's stored in some place. Zend engine is the part of the PHP core which does that. We call them virtual machines because it almost acts like an actual machine. So it takes our virtual assembler and runs it. But here's the comparison. So we have bytecode, which is kind of like machine code. We have ZenVM, which is kind of like Linux. It's kind of like an operating system. So you have this level of abstraction which makes our bytecode act like it's some kind of a special assembler code. So to run through the steps, the first thing we had is a little AST tree of our source code. The next thing we did is we generated a list of commands, a list of opcodes represented here as a PHP array. And now we can run them. This is really the only thing involved in running programming languages. Like any implementation, PHP core itself, somewhere has a loop which looks exactly like this. This is like the key, the golden key of programming languages, like dynamic programming languages. And what it does is it runs from a first command to the end of the list for every single command, gets a handler for that command, makes it do things for it. If the command returns some value, it returns from execution. If it's a jump statement, it jumps to a different position. And if not, it just keeps running through that list. Again, depending on implementation, this loop might look much more complicated, but in reality, it usually is just this. It's just all it is. A little simple loop. We're just running for every command. And when it comes to implementation of actual opcodes, all we have to do is we have to play around with this concept of a frame, a piece of memory where we're storing variables. So when it comes to assigning something, the opcode itself has a variable name, or I guess usually a variable index. And when someone calls us, we just take whatever the value is, and we store it in a frame. If we have to return from a function call or from a program itself, we take whatever value is on the top of a stack, and we return it back to execution. That's all involved. An interesting thing, though, and the one where I spent the most time probably agonizing about, is how do you do function calls? PHP has these interesting complications because, for example, it has access to global variables. So my function, which has its own scope, can still sometimes access the parent scope. That's what was the implementation hurdle. But when it boiled down to actually implementing it, when it boiled down to figuring out how it works, all it is when it comes to calling a function, I'm basically running the same execution loop just for the function inside. So all I'm doing is creating a new memory frame, which I'm saying is this function has a new memory scope, so all the variables inside the function are not accessible from outside, but it also has a parent scope, which if you have global defined, I can still access things in the parent scope. And then I'm just running the same interpreter. So it's a nested interpreter run. And this is when it clicked for me. I was like, when PHP says maximum nested level reach, which is, I think, by default 100, it says that to you because this is how it's implemented. So it can't let you keep creating these nested frames of data structures. It can't keep letting you calling nested functions in of itself because that takes a lot of resources and eventually duplicates so much memory, or at least in my case did. So that's why most of the languages have nested limits, because to implement them, you also have to nest. You keep having to go deeper and deeper and deeper. So eventually, when I was running benchmarks, I was like, well, if I'm calling a function from a function, and at the 10,000th level, I'm trying to access a global variable, then it has to go through 10,000 data frames to figure out where the variable is back. It becomes super tricky. So that's why languages limit you how deep you can go in the nested recursive calls. And that's why some people would say, oh, recursive functions are slower than implementing loops. Like there's a classic example of programming which is implement a Fibonacci sequence. The easiest solution is to use recursive functions for that, but actually the fastest solution is to use loops for that, because a recursive function is expensive because we have to do this. That's why recursive functions are more expensive. We have to create new scopes of variables. We have to figure out where variables went and went back. It's a bit more complicated. So we can't really optimize them. So if we want to define that, this is what happens when we are talking about parsing PHP and running it as machine code. We parse every line of source code. We come up with this fake assembler code we call bytecode. We cache it or we don't cache it when we run it in our virtual machine. That's all it is. But an interesting thing is our virtual machine can be written in anything, because the actual machine code which gets executed is the machine code or our VM calling low-level operations. So ZenVM is implemented in C. That's the compiled part which ends up actually generating these machine codes. My Python code is what we can call as the one calling the machine codes, because that's the last step which actually ends up calling system I/O or printing things or accessing memory. So why does anyone want to do this, and why has Facebook spent years trying to come up with their own implementation of PHP? Of course, it's all about performance. The competing compilers exist because people are always trying to come up with faster ways to run code. If you can run something faster, it's always, always better. I don't know if you just saw it, like I was just reading this morning that ASP.NET just became like 10 times faster because whatever new thing Microsoft released just made it that much faster. So if you can make these sort of improvements, it's amazing, and that's what Facebook tried to do. Why does it apply to PHP? Because I guess PHP is kind of slowish. So some people would say, well, PHP is slow. Facebook said, PHP is slow. Let's build something faster. And I kind of thought about it as well. Like, I'm running this bench file. What I can do to my source code to make it faster? What I can do to my implementation to make it actually faster? Like, how I can beat the slowness of PHP? And the reason why PHP is slow as compared to, I don't know, things like C is because it's not specialized. So another lesson I learned is that if you want to write fast code, the only way you can achieve that is by specializing. When it comes to execution of languages and execution of like programming language level optimizations, you specify by using types usually. So there's the first thing. If you don't use types, which PHP doesn't use types, is you can't really optimize to the same degree as C would, because C is specialized. C knows what the variable type is. And I was listening to one of the core developer talks of PHP, Nikita, and he said that PHP has come to the point where you can't really do a lot of clever hacks anymore to the source code of it. The only way you can optimize it is by reducing memory structures and making less I/O to memory. That's how languages nowadays get optimized. Just store less in memory and access it the least amount of possible time. If in PHP case, if we're storing these generalized data structures, so if you try to store a list of a million integers, it takes much more space than C would, and because it takes much more space, it is also slower. I really tried to implement the eval function in PHP. I couldn't figure out how to do it. So the problem with eval, and I guess the reason why, I don't know, why C doesn't really have eval, I'm sure there's a way to do it, but why C by default doesn't have eval, because eval requires us to run through the same 3 steps at execution time. So now we have to ship our source code with a living parser and a living compiler inside of it. So again, we can't generate a slimmed down version of our execution if we have to also ship a parser. In PHP case, it's not a big deal because we're not shipping actually compiled PHP, but in C code, we can't just ship an executable which also contains all of the C toolkit just to be able to compile things at runtime. So when it comes to things like eval, if you want to support them, you give up a lot of extra performance, I think. All these crazy dynamic features, all these things like magic access and all these crazy things, they work fast-ish, but they are never as fast as direct access because on every access, on every command PHP runs, it keeps having to figure out what exactly are you doing. So the less of them you use and the less of them programming languages have, the faster it can become. So for example, JavaScript a couple years ago had this thing called assembler.js, which is just a subset of JavaScript removing all the slow parts, so kind of removing everything, I guess. With assembler.js, they removed all the dynamic crazy call things, which I still think is just all of the JavaScript. But they removed all of it, and they can compile it and be as fast as C. It's pretty interesting. So how do we achieve that? Like, I talked about specializing code. We can only do so much to optimize our source code by parsing it cleverly or like by storing some crazy caches. We can only do so much. So how we can specialize it and still use dynamic functionality? Well, it's called JIT. Anyone has seen this term before? Yes. So most people have heard of it before. I guess in PHP it was made famous the most by Facebook in their HHVM implementation. It's been used in other languages and in other environments. What does JIT mean? Well, it means that instead of us specializing code ahead of time, instead of us coming up with these great data structures, instead of coming up with fast code paths, we just let the code run. And then as it's running, we're collecting statistical information, and then we're using that to recompile the code at runtime. And you might be thinking, whoa, so you're recompiling the code as it's running? That sounds slow. It's actually not that slow because we let the code run for 1,000 times, we figure out the parts of code we can really optimize, and then we compile them to optimized versions of them, and then we replace them. So if you imagine a website, if you leave it running for a week, a day in, it's faster, and then it becomes faster and faster as it runs until it reaches the maximum point. Again, depends on the source code, there's different things involved. And that's what allows dynamic languages to be really fast nowadays, is that we can optimize them on execution. And that's like, I think it's the right way to do things for most people, because I don't have to think ahead of time how I can tweak this data structure, how I can tweak this code path. I write my code as fast as I can, and I let the compiler to figure out these sort of things. So PHP core itself doesn't use that yet, but I'm sure in the future we might see it. So it gets used in practice in this way. So here's a piece of the PHP bench file. And the thing it's testing is both loops and then accessing variables multiple times. So the question is, can you optimize this source code in any way? Like, is there anything you can do to make this faster? Outside of rewriting it in different languages? Probably not. Like I don't see any performance drains. You can probably do some micro optimizations, make the variables shorter. That's going to make things faster. But outside of it, there's nothing you can do. Like, that's as fast as it's going to get. But if we run this code, we very easily and very quickly realize all these numbers are integers, and all these variables are integers as well. So we don't have to check of them being integers. When we have to check, is this variable less than a million? We don't have to check, are these both integers? And like do this crazy type manipulations. We can just trust them to be integers. So we let it run for 1,000 times, and then we compile it by figuring out hot loops. A concept of a hot loop is that we detect parts of code which get called a lot. So they get called so many times that we know with statistical significance they don't change, the path is always the same. So if it comes to an if statement, we know that it's always the true branch, so we can actually just ignore the else branch altogether because it's never actually getting called. Also, we can figure out the variable types because we know it's always an integer. We checked it, now we can just remove all the checks for variable types and just let it run as if everything is an integer. And of course, with dynamic languages, there's still some kind of a path from somewhere where I can maybe call it with a string, but then it would just crash like on running, recompile it again, and then keep running anyway. So yeah, that's how you make dynamic languages really fast. Is you can't really optimize parsers and interpreters that much. There's a boundary, but you can optimize data structures really, really, really well. And that's what made PyHP very fast as well, is that it uses JIT. So when it came to PyHP, which is, again, it's all Python, it actually uses this open source project from Python world called PyPy. So Python also has a similar problem where Python is actually a very slow language. So they tried to fix that by creating a competing compiler called PyPy, in the same way Facebook did that with HHVM. So they built PyPy and built together with that a subset of Python called RPython, which you can use to build interpreters, and that's what I used. And because it comes with all these tools, for me to enable JIT, it was just a bunch of change of lines. I change them, it works. And because it's still all Python, it's unit tested, and you can run it as a normal Python program and just, it works. I think it's a total of a couple of thousand lines. So it's super easy to read. And if you want to make it fast, then you just run through this RPython compiler stage. It generates a fast executable when you use it. So you might be thinking, why on earth would you do this? Which is right, a right thing to ask. You should definitely not do it. But I did it because I realized, well, if I want to look at the PHP internals, there's no way I can figure things out that quickly. So when it comes to execution loops, like, yes, now I have found that loop in PHP, and I can kind of see how it works. But if you just look at it, like, it's just too much. And like now I've had people like ask me, like, oh, so how does PHP do like comparisons from a string to a float? And I dove into the source code of PHP, and I looked at the C codes and all the thousands of lines. And it kind of makes sense now, but to start and just go all deep in, just didn't feel like something I want to do at my free time. So that's what I did instead. So it was super easy to write it in Python, and it still did all the things I wanted to. And now I can actually prototype any PHP feature in a matter of minutes. So when it comes to adding Unicode support, I just changed all the strings to be Unicode in my Python level, and all of a sudden PHP became Unicode. And when it came to adding output buffering, I just added this variable where I'm storing the output as a string, and then that's it. Like, that's what these tools allow you to do. So if you want to try it yourself, there's a few things. So first of all, there's a PHP interpreter written in PHP, which is a fun one. So if you want to play around with interpreters, and if you want to look at how they work, and if you want to try them yourself, PHP is the one to use. Again, it does all the things you expect it to do. You can implement your own features. You can replace the $sign with a pound sign and run it, and it's super easy to do that. If you want to try the Python version of that, which is similar to the PHP one, just faster, you can do that as well. It's all on GitHub as well. If you want to use any of this for production, HHVM, of course, is the tool to use. HHVM is a stable JIT interpreter built by Facebook. So if you have production loads or you just want to experiment with JIT compilers, HHVM is the one to use. Again, everything is on GitHub. Yes, there's one more thing. So I talked about the fact that our VM is the last step which does the actual machine translation. So PHP core is written in C. That's the part which does the actual calls to the system level. My thing is written in Python. That's the part which does the machine calls. So you might be saying, so where you can push it more, like what more crazy things you can build then? Well, since our VM can be built in anything, it should be built in anything. So I present to you a new revolutionary project which is going to change the lands of PHP. It's called PyHP.js. And it is actually a real thing. It's not just a slide. It's a real thing, and it works. And what it is this. So it's a Python compiler written in Python, which then gets compiled to C code. Then that C code gets translated to JavaScript. And then you take that JavaScript and you throw it at the Node.js runtime, and it works. You can also do it in a browser. So you can take your PHP application, and then you can run it in the browser and laugh at how it crashes. This is how it looks like. So that thing it's a PHP file. Then I have a JavaScript file which is created by compiling Python to C to JavaScript. And then I have a Node runtime which runs the bench file. So if you ever ran bench file, that's what you've seen. You might be wondering, why on earth is it that slow? So it takes 24 seconds. I think PHP 7 takes 1 second. It's that slow because I have no idea why it's that slow, because the PyHP.vm.js is a 24 megabyte JavaScript file full of numbers and like loops, and I have no idea how it even works. But it works actually. So it runs any PHP you want, any PHP supported by Python. And kind of jokingly and realistically though, a neat thing about this, and a neat thing about PyHP.js is there's two things. First thing, it's not translating your PHP code to JavaScript. It's not trying to replicate PHP functionality in JavaScript. It's an actual PHP VM running as a JavaScript implementation. So it does its own output buffering, it does its own I/O, it does its own access to memory. All of it is implemented in JavaScript. Which means, and that's the second part, you could use similar tools like that in the future to run PHP in any environment which supports JavaScript. Like recently, Mozilla built Firefox OS, which used apps built with JavaScript and HTML. And you could use that to run PHP on your phone. And I think once they saw me give a talk, they just recently shut down Firefox OS because they're like, we don't want PHP on the phone. And then recently I also learned that MySQL now has JSON support. And I'm pretty sure they're not willing to admit that, but soon enough you'll be able to run JavaScript as MapReduce, for example, for your MySQL data. Yes. I can't wait for the day when I'll be able to run my Symfony app inside of MySQL and then use MySQL as data storage. That's like the ultimate web scale. And this actually idea comes from this talk I saw, which is much better than the talk you just saw, actually, by a lot. It's called The Birth and Death of JavaScript. And this super funny guy, DestroyAllSoftware.com, talks about the future of JavaScript and the fact that since we have now these crazy smart compilers which can compile any C code to JavaScript, you can run things like Firefox instead of Chrome, instead of Safari, because ultimately everything boils down to C, ultimately everything can be boiled down to JavaScript. Completely useless, yet it proves my point that my VM can be written in any language because all it's doing is just running a bunch of bytecode. Does anyone have any questions? Yes?
Yeah, can we bring the mics in? Because it's better if it's recorded. There we go.
If you're going to ask, does it support Laravel? No.
No, I wasn't. Back on the slide you gave about the hot loops thing and the optimization, you said, is there any way that you can optimize that? And looking at that, I'd argue that there is a very obvious way you can optimize it. Don't call it. It doesn't actually do anything. There's no references going into it. There's no return value. So would you argue that...
Or you're saying that the fact that it didn't have a function call for that function itself?
No, as in all the function does is it assigns variables inside its own scope, increments them, and then exits. It doesn't return them. So should a compiler optimize that out because it actually doesn't do anything? Or are the secondary characteristics like execution time and memory use something that a compiler should persist?
I would say the smart compilers actually do look at unused dead code. And I think a good JIT compiler would realize the fact that you never actually called or you never use a variable and would actually just never call it. I'm not sure if my one does. I'm not sure if even the Facebook does that one. But a lot of them do that. A lot of them do that. Like even if you go back 10 years ago, when PHP 4 had these opcode optimizers, like Zend optimizer and then X optimizer, whatever, what they would do at the time, they would do the same thing just on the opcode level. So they would look at the opcode and figure out the paths which are never used and then just remove it and then optimize your code, which it did by removing things. You're 100% right. Yeah. But that's also like not exactly trivial. Detecting dead code is not exactly trivial. You have to, not exactly trivial.
So I have two questions regarding the assembly stage. Is it possible to tell PHP in some ways, if you like put on your Superman robe and think you're smarter than the compiler, to tell it to maybe unroll loops and stuff like that? I mean, it's normally...
If I'm not mistaken, PHP doesn't unroll loops yet. Not yet.
Okay.
But some compilers do that. Some compilers do unroll loops.
But I mean, in some certain cases, when you're really like at dead end and you think, okay, I just need raw speed right now, and I have no way of getting like this code better, and I know that, I mean, I have a lot of memory, so there would be no problem in putting like a hell of a lot of opcodes.
Right.
So you couldn't. So not right now.
Not right now.
Okay.
It's possible, and some languages do that. What he's talking about is just replacing a loop by just replicating the loop as many times as the loop runs. It's called unrolling loops.
Okay. Next thing is, how does like PHP and I mean any compiler handle the thing when like dynamic names and dynamic typing? I mean, if you have like this long variable name assigned to an integer, and then suddenly down some guy have like just assigned a whole array to it or anything like that.
So variables.
How does it work?
In dynamic languages, a variable is always boxed. So it's represented by a bigger data structure. So your variable is never actually has an int. It has this structure, which in PHP is called zval. In my own, it's just an object which contains the actual integer. So if you decide to change that to an array, the variable stayed a zval. It's just the inside of it now has a different, like, low-level type.
Just follow-up question to that. Would you, I mean, if that were to happen, is that like, I mean, is that bad for performance? Like
That's bad for memory usage, if anything.
Okay.
Because every PHP variable takes 56 bytes, some amount of bytes, which are much larger than a single variable would be, because a zval says, oh, I have space for an integer, I have space for a float, I have space for a string, I have space for all these different things. And it's only one of them actually ends up being used. But that's what you need, because if I have a comparison function, the comparison function accepts two zvals, unpacks them, figures out if it compare them, so when it does like string to float, it has to do all these crazy things. And then it returns whatever float wrapped again in a zval. But you can't just build comparison functions for all the different matches of types, and because there's no types, it's all just packed in a box structure. I did the same thing. Like in my little project, every variable is represented often in an instance of type variable. So as a float just extends that variable class. But as far as the kind of the low level is concerned, when every variable is of the same type. That's what you need, basically, to have the same type. And it's slowish and memory consumption. That's what PHP 7 is so much faster, because zvals now take less space for most of the clauses. Does anyone have any more questions?
Yep. So very briefly, have you any idea what you just did to DevOps, and what are we going to use on April 1st when we can't use the PHP for the front end gag anymore?
Just use JavaScript for everything.
I was just going to ask, does the PHP 7 scalar type hinting help in terms of optimizing how it stores variables? Do you know?
If I'm not mistaken, not yet. I don't think it's used yet for execution.
Right.
Optimization. It could be used in the future, I would say. I can't see a reason why not.
Yeah.
Because that would help a lot. It doesn't fit in the slide, but basically anytime you access a variable in PHP, it has to, anytime you try to compare it or do anything with it, it has to basically do an if statement and figure out what type is it and do all sorts of crazy migrations. So anytime you have a string and you compare it to an integer, yet over again, it has to compare types, figure out that we don't match, loop through this thing trying to match a type matching group. So it has to cast strings to ints and do all these crazy things.
It seems like that would be a really simple performance, big performance
Maybe
hit.
you should contribute that. Yes. I'm sure it's up. Yes, it sounds obvious and simple. To be honest, I don't know why it doesn't do that yet. I'm sure it's not that simple, probably. Nothing ever is. I think PHP also tried to, as far as I know, PHP also tried to have JIT for PHP 7, but the prototype, which Zen, the thing built, ended up actually being not that fast compared to what PHP had anyway, and it introduced so much complexity, they ended up not adding it in the first place. But I can't see it being added in the future. It's just usually for a project like as big as PHP core, even the simple things sometimes take a long time because it's so low level and there's only so many people who know that stuff, which I'm not, so I don't know. I'm just talking. Any more questions?
I kept thinking of how templates, generics work. So if you have like a method that depends on a type, which is a list of something, and that something is not defined at at the template level, at the generic level.
Mm-hmm.
And then if you have something like that for the zval or zval, that what you need is that you get a list of something and you don't know what the something is, and you can use the other field to determine what the field is. And the worst that can happen is that you end up having a list of an integer with just an integer inside, or a list of an, and that would be maybe something to explore for PHP.
I don't think I get your question. No.
Do you want me to repeat?
Yes.
Okay, so so if you have like the concept of generics or
Yes.
Yeah, templates. So imagine that you have a list of something.
Okay.
Yeah, as like an abstract type, and that's something. And then your Z-val, the struct in Zend, we have the name of the type as one field of the struct, and the other one, the value, will be a list of something.
Yes.
So if you say the type is an integer, the value is a list with one integer in it. If it's a hash table, then you can have a list, a more complex list, similar to the hash table that we have in Zend at the moment. So that probably it will save memory space, or not.
I don't know, to be honest.
I don't even know how it works, how you kind of account for that in the memory and have a list of a generic.
It's, no one knows.
I'm just like, okay, I'll try myself.
No idea.
I'll write a compiler.
That's right. Yeah, try to fix that. Oh. Any more questions? Okay. Just a small point. If anyone wants to try it, my little thing, it comes with a Docker file, so you can just run it on any Linux or any Mac OS or any Windows machine, because all the dependencies are inside of it.
Very cool, by the way. Just one question. On what level, like in the opcode or below, would you try implementing something like tail call optimization for recursion? You know, instead of increasing the stack by a frame, just going to a label.
This question is on what level, though? So it goes on opcode level. Yes. In the execution loop, you would try to figure out that.
Sorry?
I think you would do that in the execution loop.
Okay. Thanks.
I think you would just have to try it. Like when I try, like even with the simple things, I was like, so how do I do output buffering, which is a global variable accessed by any context, and it breaks a lot of things. So I spent like 2 weeks trying to figure out how to do output buffering. But any sort of optimization, any sort of these global concepts end up being pretty complicated. Yeah. Or like even things like passing things by variable end up taking a lot of time, because passing things by reference. Yeah. So when it comes to optimizations, like it's funny thing you can see, like PHP actually, the core even has basically a folder called optimizations. It has a bunch of these optimizations. And depending on what sort of optimization it is, you can either run it on source code level, on a parsed source code tree. You can run it on the opcode level. It depends on what information you want to know about it. So opcodes are more about execution. Source code are more about just the raw of it. So in the source code stage, you don't know what's going to be called yet, because it's just source code. And on opcode level, you know actual access patterns of things. Well, the optimizers are very difficult. Someone said like writing a compiler compared to writing a JIT compiler is like day and night. So writing a compiler is easy. Writing a JIT compiler is 10 times more difficult, because writing these optimizers on arbitrarily source code files is pretty damn complicated. You have to take into account like memory, CPU speed, and compile time, and figure out which is more valuable, which you should do instead of doing a number one.
You can probably take one more question. Just enough time for one more. Check the room.
The other room is trying to compile JavaScript probably.
Stunned faces from the other side. That's all I see.
So I think it might be hard to take in. So if you have any questions, you can tweet me or just drop me an email. Even if you have questions about how internals function, I will try to pretend like I know, and I will try to help you. But that's also like a learning experience, by like having questions and then trying to figure out how these sort of things function. It's an interesting thing to learn. But I hope that you now have a better understanding of, I guess, why PHP is not as fast as C code. Like, what is the actual reason, and why things like JIT compilers make it faster, and how things like opcode cache do, and what this actual opcode thing everyone keeps talking about. That's it.
That's wonderful. Thank you very much.
Thank you.
And you heard it here first, pyphp.js.